Good evening, and welcome to another episode of me trying to get my game to work. Okay, so in my level I have a temple, like a big bulk temple door. At the minute, the design's pretty simple. This right here is the door, and it will slide down when you solve the puzzle. The puzzle being this ring here, it's like a combination lock. So you've got an inner ring, ring 2, ring 3, ring 4, ring 5, and the outer ring. So there's about 6 rings, and they all spin. Now they only spin when you're inside this area here, all these cubes when you're in here. And it's mapped to 1, 2, 3, 4, 5, and 6 on the keyboard. So let's see if we can solve the puzzle. Here we are in the world. Fantastic. And I should get a debug log at the top left of the screen when I know I'm in the right place, just up here. Okay, so I've got a little bug that says in 1, in 2, in 3, in 4, in 5, in 6. And that's out, in, out, in. So that'll just, just let me know if I'm close enough. And when I push these keys, different rings move. So I'm pushing the 5th key here, 3rd key here, 6th key here. First one will move the inner ring, 2nd ring, 3rd ring. You get the picture. So if I press T on the keyboard, what will happen is this pin here will move down slightly, and it will double check, or check actually, if the combination is correct. And it will give me some lights as well, 1 to 6. Let me know which ones are right and which ones are wrong. And I'll demonstrate that now. So I'll press T. As you can see, they're all wrong. And then these lights disappear. You see them appearing, and then they disappear. So the bottom left was the first ring here, the inner ring. So let's try and solve that first. So let's do that. Okay, so that first one is now correct. Fantastic. So we don't need to do any more on that one. And we've got the second ring sorted. Now, just for the sake of testing this, if you notice here, the correct combination is like slightly raised out. So I can see the difference. I can see that that is now correct, potentially. Yeah, there you go. I don't know if you can see that on the recording, but that is the case. So anyway, that's just so I can debug really fast. In the build of the game, this will all be flush. There won't be any of them raised down, and they will be different symbols on textures that are on there, much like Stargate. If you've ever seen Stargate, it will be a glyph or a symbol, and you'll get those symbols from various other locations in the game, which is yet to be sorted out. But you'll get them, and then there'll be different combinations of those 6, and I'll leave some hieroglyphs that are fairly nondescript so that people can figure that out. And I'll be able to get into this temple where secrets will lie. But for now, it's just a puzzle in my testing map. So let's go ahead and solve the puzzle. And you should see this door move down if I've done it correctly, which I have. And then the door moves down, and we have access. Cool. And then that's just the rest of my testing map. So I'm going to come out of here now. Excuse me. And I'm going to show you exactly how this works, so references, mechanics, and I'll try and keep it as short as possible. So the first thing I talked about was if I was in this area. Well, how do we know if we're in this area? So this area here contains a collision, and another collision, and another collision, and another. It contains 6. Okay, they're all slightly out of line, but it contains 6 colliders. So where's that in here, you might ask? Well, good question. I'll try and find out where I put it. No, it's fine. We'll find in content browser. Okay, so this is an actor that's called a button. And the button is a command in Unreal that can fire an event somewhere else. Don't get too held up on that at the minute. That'll become apparent later on when you read blogs and things that I've written. But just for simplicity's sake, that is a game object. And all it has in it is a box collider. That's it. That's all it is. It's a box collider. Okay? Just waiting for it to save. Before I can show you the rest. In this object as well is an event graph, which is a blueprint, which is how most things in Unreal are used and fired and how the logic works. So what have we got here? Well, we've got events actor begin overlap. So when this box overlaps with the player, it sets in trigger, which is a boolean, true or false, to true, which is tied to this if statement. Branch is just an if statement, FYI. And it will fire an event and print text to the screen saying in one. So that was up at the top left when we first started the game. The node event actor end overlap. So when you finish overlapping with this box trigger as a character, it sets in trigger to false. The branch fires, it comes out as false, because this in trigger variable is a condition of that. And it will fire an event dispatcher called button F, button false, button T, button true, and it will say you're out of that collider. Now, I'm saying, why don't I just print these strings, true or false? And then, because this variable has been called and this is a collision, effectively, why do I have these? What are these? Well, these are called event dispatchers. So, although, in theory, if I didn't have these, I could still print to the screen and the game would still know if I was inside or outside of that button, it wouldn't necessarily enable me to do anything else with any other object in the game. To do that, so they can communicate with each other, I need something called an event dispatcher, which is here. So it's kind of like a variable, but it's something which is called upon logic. So if this is true, it will call button T, button true, which means I'm inside, and obviously false is false. So these can be referenced somewhere else. This is what this little envelope means. Okay, it means it's kind of it's global. It's global. It's not private to this one button. It can be, but it doesn't have to be. So you're thinking, right, well, where do I call that? So when I'm inside, what's the point in calling that somewhere else? Well, when I'm inside, I want to be able to rotate the rings. I don't want to be able to rotate the rings when I'm anywhere else in the level. Like if I was all the way over here and I press 6, I don't want that to rotate. Okay, I want it to be controlled. So let's have a little look at how that's called. And it's in our level blueprint. Now the level blueprint controls the whole level, so you can put references to any objects you want in here. And it's not self-contained, like it's your entire map, basically. Your entire game build is in here, the logic for it. So if we've got a combination lock ring or a temple ring or a gate ring, whatever you want to call it, and this event dispatcher communicating with each other, this is where you want it to be. So let's find it there. So this is where it is, okay? So in that old blueprint in button 1, which remember I've got 6 of these. So this is T. That's the event dispatcher that gets called. So when I'm inside and these are set to true, it calls this event dispatcher in my level blueprint and it goes, okay, I want you to open this gate. Side note, a gate is basically an complicated if statement, yeah. The condition is I press 1, or when I press 1, and this is true, this is fired, the gate's open. When I'm not inside that, this is fired and the gate's closed, so this won't be relevant anymore. So anyway, I'm inside, gate's open, and I'm pressing 1 and 2, so I'm going to enter the gate. Okay. And what will happen then is it will rotate, add actor local rotation. It will rotate 30 degrees on the yaw, and it will say you've moved ring 1. And you're thinking, okay, the ring's rotating 30 degrees every time I press 1 on the keyboard. That's great. Why have I got 12 actors referenced here? They're the targets, and the reason is because I have 12 pieces that this ring is made out of. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like this. They each have their own collision. I only want to check the correct one. I don't want to check, is this ring here? Yes, because then it will always just solve the puzzle outright. So that's my way of sort of separating the ring into 12 pieces And obviously 360, which is a full circle rotation, divided by 12 is 30. So that's where I get this number from. So that's fine, you know. If it was 10, this would be 36, for example. I really hope that makes sense. And by saying that, I hope that wasn't condescending. So this is ring 1. This is ring 2. Okay. This is ring 3, and so on, you know, 5, 6, whatever. Now we've got different event dispatches here. So we've got button T2. So before we said button T, we've got button T2 now. Why have we got button T2? Because button T2 is inside button 2, yeah, which is that second collision. Remember at the start I said we've got 6 colliders that are all here, yeah, overlapping on top of each other. And T2 controls the rotation of all of the rings, all of the glyphs that make up ring 2. So that's just the way that I separate, excuse me, separate the rings with the button press. Otherwise, all of them would rotate when I pressed any button, or all of the glyphs would be true because it'd be one object rather than 12 that seemingly make up one. So that's fine. So, okay, I'm rotating all of these 12 parts in unison, so it looks like it's one ring rotating. Really, it's just 12, but they're all spaced out evenly, so it's fine. You're saying, how the hell am I actually checking if the puzzle's solved or not, or if the lights are spawning, or so, you know, how did I get all that working? The way that works is behind the scenes, which is like literally behind the ring. That was so lame. Okay, so what that is each one of these little parts that make up the rings, each one out of 12, has a little collider. You can see it just here. You see this here, this really tiny flat plane, yeah? Here. That's at the bottom of each one of these pieces that make up the rings. So that's where you can see sort of here, this weird oblong, you know, rectangle, rhombus, whatever. Here it is, there. We can get that up in a blueprint if you want as well, so you'll see these actors. So this is basically it. 12 of these make up one ring, but they all have this box collider here. Now what this box collider does is, that is how I check if this is the correct ring, correct symbol or correct combination lock. That's how I check the order of these things. I use an on-collision enter with something else and this. If those two things collide, then that ring is correct. Now the thing that collides with it is this. Okay, so what happens when I press T is this thing moves down, excuse me, collides with this collision on the temple piece, and it goes, okay, I'm going to run a check. If you are the correct piece that I'm looking for and I've collided with you, give me a green light. If you're not, give me a red light. Okay? And that's very important. Now, I might even be able to check that from here. You might see these move down when I press T now. Did you see them move down? I'll do it one more time. There, they moved down and they moved back up again. So what that did is it ran a check and it says, are you tagged as the correct one? And it went no, so it gave me red lights. All I did to make that correct is I just tagged the correct ones. So the pins, the glyphs that are correct, I tagged and said, okay, if you're tagged as this, then you're unlocked. Okay, so we've got how I move the rings. We've got how I check the rings. We've got how the rings are made up of 12 different pieces and how they all have collision. How do we then execute the logic of the pins moving down, pressing T, and running all those checks? Well, for that we will have to go back to our level blueprint. And what I want to cover first is just that, you know, that check of pressing T. So if I go back here and you have a look at these little blocks, I called them temple pin. It's like a little pin moving down. I thought it was a nice way of checking. When I press T, it moves down and up again. And there's 6 of them, because there's 6 rings, I need to do 6 checks. So every time I press T, I fire this timeline, and it moves this temple pin down and up again. Now, I don't want to get into timelines now, but what timelines basically do is it's an animation, okay? And I've looped this animation, and I've said here, play from start, okay? So all you need to know is this is an animation that lasts 1 second, and it fires and then resets, okay? It's just a simple timeline. That's all that happens, okay? Well, it's actually 0.3 seconds. And that's what happens, that's it. I won't go into timelines now, it's too long. These are all sorts of variables, so it's the initial location of the pin. I want to play that from start and get its world location. And then I add that to the amount I want to move it to, set its new location, and then I reverse that process through the timeline, so it moves back up again. So all of this moves it down, and then it reverses again, which is nice. Now, one of the main things I didn't want people to do was spam T. So if they continually press T, like crazy, like, what would happen is, because the timeline is 0.3 seconds long, if they were holding T, T would be pressed 0.001 times a second. Sorry, every 0.001 seconds it would call. So what I found was happening is the pins, if people spam T, were just continuously moving down, and it completely broke my collision. The whole thing failed. Because the 6th one had moved all the way down to the first one. The first one was through the floor. It wasn't very good. You know, and people did that a lot. So I had to make variables, which is get the world time in seconds, and I've got a wait time that you have to wait before you can push it again, and the amount of time that's passed since you pressed T, okay? So if the amount of time you've pressed since you last pressed it is less than the amount of time I want you to wait, which is 2 seconds, then do not fire the timeline. If it is, and you've waited long enough, then fire the timeline. So that's just a little side note of user testing. Okay, so that's how the pins move, and that's how the collision works. Now, the most important sort of thing for me to cover in the next couple of minutes is the logic of actually opening that door. So I'm going to take you back to the temple pin that I just talked about, because this is the thing that's moving down and doing the check. So I'm using again on actor begin overlap, and I'm saying on the first pin, which is just behind the first ring, if one of those 12 sections has the tag ring 1 tag, which is the tag for the correct one, then I want you to say pin 1 is unlocked, meaning you've solved the first ring. That is true. I want you to spawn gate light correct, which is the green light, at that specified location, you know, when you could see it pop up on the screen. And then I want you to survive for 3 seconds, say that I've unlocked the first ring, and do an event dispatcher, which is unlock 1. If that actor, so any of the other 11 pieces that make up the first ring, doesn't have this tag, you spawn a red light at the same location. You still kill yourself after 3 seconds, otherwise what you end up finding is you have correct lights and wrong lights in the same place. So I had to kill it. I had to tell it to disappear. Spawn a red light anyway, and just, you know, don't tell me anything. And you don't fire an event dispatcher for this, because if you get it wrong, the player will just try it again. He'll move the ring. Or they will move the ring. Beg your pardon. So, you know, I don't need to call anything. It just ends there if I've got it wrong. But if I've got it right, I call this event dispatcher unlock 1, which, as we talked about earlier, I can reference in the game logic of my whole level in the level blueprint. And that's here. I don't know why it's the third one down, but whatever. It's here, and this is one of the booleans that will fire in here, which I call gate 1 unlocked. And as you know, 1, 2, 3, 4, 5, and 6. And each one of those temple pins has their own little unlock 1, unlock 3, unlock 2, whatever. Event dispatchers. Now, this is what makes that puzzle work. So, I've said, if you fire all of these 6, okay, and the booleans are all true, and the booleans are all true, this is important. This is the most important node in here, because otherwise, if I just attached it to the if statement, if any one of these was true, it would solve the puzzle. So I've set this limiter here. It's called an AND. You would know this in code as AND symbol. And if. Okay, if that's true, I want you to fire another timeline. And the target here is, it's exactly the same timeline as the pins, apart from this one only moves down. It doesn't move back up again. Just moves down. And the target's the temple door. And I want you to set that to its location. So that is it just moves down. If all of these are true, literally all of them, nothing else will work. You can't break my game. If one of these is true and you fired this statement, then this will fail. It will receive a negative result, because it's not all of them that are true, it's just one of them or 5 of them. You need 6. If you only have 5 or less than 6, it will return false, and it will set all of these booleans back to false. Now that's important, because if you solve to the first ring, and then you solve the second ring, and you move to the first after that one, in that scenario, without this reset, the first one would still be set to true. So you could just sequentially mash the first one until you got it right, then mash the second, then mash the third, and it wouldn't matter if you knew the combination or not. So this just resets them. Every time you get any one of them wrong, all of them become reset, which is good. And this spawns another little light that I'm not using at the minute, but it was just to let you know that you got it wrong using 1 light instead of 6. But that still appears. You might have seen it in the little video. It goes beep beep, and then it, goes away. So that's not really important. These 3 nodes aren't really that important. And that's it. That is me rabbiting on for 24 minutes on how to get a combination lock working on a door. Now, you might just be wondering, where do you get these variables from? I'll give you a quick rundown of how that works. It's basically just the global. You just hit new variable here. Gives you a new variable. You select what kind, whether it's like a boolean or an integer or a float. Call it what you want, and then you just sort of drag it in. You can either get it, plug it into something, or you can say, I'll drag it in and I want to set it to false or true depending on whatever logic happens. That's it. So that's absolutely fine. Yeah, I hope that wasn't too tedious or boring, or I hope I didn't assume a lot of other knowledge there. Yeah, I hope that's easy to follow. Okay, thank you very much. Over and out.